Hey everybody, Mr. Murray here, back on Mr. Murray's Math Land, and talking about a different type of factoring today, which is called the difference of two squares pattern, or as I like to call it for short, DOTS, difference of two squares. Okay, so take a look at the first one, part A here, x squared minus 25, and we're trying to factor this. Now, you actually could approach this the same way you did your unfoiling if you were really stuck and you didn't recognize this new pattern I'm about to show you. And you could treat this as, hey, what two numbers multiply to be your constant, which is negative 25, but add up to be your middle term, which remember, there's usually a linear term, a bx term in the middle, and there's no x term here. There's only the x squared and the constant, which is like saying, hey, they must add up to 0 because there's 0x in the middle. And then you can, probably pretty quickly say, hey, that's got to be 5 and negative 5, which means this could factor to x, and one of them plus 5 and one of them minus 5. It doesn't really matter the order, as long as one is plus and one is minus. And again, you could check that very easily by foiling. X times x squared. Your outers will give you negative 5x. Your inners will give you plus 5x, and they will cancel out, giving you 0. And then your last will give you negative 25. So you can definitely think about it that way. But it's also nice if you notice, if you have two terms, and they're of the pattern a squared minus b squared, meaning they're each perfect squares, then it will always be able to be factored to a and a, right? Because that would multiply to give you a squared, plus minus, doesn't matter which one's plus, which one's minus, b and b. And that's really what happened here. So this part b here, x squared minus 49, if you happen to pick up on this, it's like, what squares to give you x squared? Well, that's x and x. Minus 49. 49 is a perfect square. What squares to give you 49? Or in other words, what's the square root? 7. 7 and 7, but 1 plus and 1 minus. And there you go. Check by foiling if you like. So it's really just, it's a great, pretty easy pattern if you can pick up on it. And of course the problems can get a little more complicated, so we're going to take a look at some of those now. But that's really it there. A squared minus b squared, and it's got to be a minus again because this is called a difference. Difference means minus. There's got to be a minus in between the terms. Difference of two perfect squares. So here we've got our minus, our difference, and are these both perfect squares? Now they're looking a little more complicated, and this is going to be factorable. If you have trouble seeing, what's your A and what's your B, you're really just saying what squares to give you 49x squared and what squares to give you 36y squared. You're taking the square root of them. Well, that must mean 7x and 7x, and here is 6y and 6y. So that's what I'm going to do. I'm going to put 7x, 7x, and what squares to give you 36y squared? 6y. So 6y and 6y, 1 plus, 1 minus, and there you go. So even when it's not just x squared, or if there's a second variable, it really doesn't matter as long as it's what we call a perfect square. So something squared, something times itself, will give you that. And right, what times itself gives you that? 7x and 7x. What times itself gives you this? 6y and 6y. That's that. Okay, number 3 here. Now, if you take a quick look, if you're all on this dots pattern here, difference of two squares, you got the difference, but 24 is not a perfect square. Neither is 6, and neither is x to the 5th or x cubed for that matter. So don't forget that the first thing you should always look for when you're factoring is there a GCF? And is there a greatest common factor you can take out? And out of these two, yes, there definitely is. What can I take out of these two I can take 6 out of the coefficients, out of 24 and 6. And from your variables, you've got x to the 5th and x cubed. You can definitely take out x cubed, right? X to the 3rd. So I'm going to take out that greatest common factor, and then of course, what's going to be on the inside after I do that? 6 times 4 would give you that 24. I took 3 of the x's away, so there'll be x squared left on the inside. And then 6x cubed times what gives you negative 6x cubed? That's going to be minus 1. Okay, but as always with our factoring, now that we've been getting more and more advanced, you always want to say, this is the first kind I'll look for, but I want to make sure it's completely factored. So after you take something out, great, but now you got to look at that quantity there, and can that go further? And so now you really have 3 different kinds after that based on how many terms they have. And so if it's got 4 terms, we learned about grouping. If it's got 3 terms, that's where you got your trinomial, you got your your unfoiling or your AC method. Whoops, yep, that I just misspelled unfoil. And if it's got 2 terms, what you'll want to look for now is the dots pattern. So you got all your methods here, but the very first thing you always look for is that greatest common factor. And so this 4x squared minus 1 is definitely a difference. It's got a minus in the middle. And 4x squared is a perfect square. Square root of it is 2x. And 1 is a perfect square. What times itself gives you 1? 1. So this factors a little bit further, right? This becomes 2x and 2x, 1 plus, 1 minus, and square root of 1 is 1. So there we go, our completely factored expression there. Notice you still write that 6x cubed that you took out. It's still one of the factors, so it needs to be part of your answer. Don't forget about it after you take it out. And of course, if you're thinking, can it go further? You should be looking at these. None of them can go any further. This has a minus, and that's a perfect square, but 2x is not a perfect square, so none of these can break down any further. Typically, when you get down to x to the 1st, that's probably going to be as far as you can go. Okay, but take a look at number 4 here. X to the 4th minus 81. There's no greatest common factor you can take out, and there are 2 terms, so I'm going to go right into looking for dots, difference of 2 squares. And what times itself gives you x to the 4th? That would be x squared. So x squared and x squared. Sometimes they have higher powers than just, x squared. And 81 is certainly a perfect square. What's the square root of it? Or in other words, what times itself gives you that? 9 and 9. One of these has to be plus, one has to be minus. Yay, we're done, right? No, because you got to take a look. Can you go any further? And each of these has 2 terms, so you should be looking, is either of these or both of these a difference of 2 squares by themselves? Hopefully, you rule this one out right away. Difference of 2 squares means it's got to have a minus. There's no sum of 2 squares factoring. This will not break down. You can try all you want, but you won't be able to come up with anything that foils or multiplies to give you x squared plus 9 until you get into Algebra 2 and you learn about things like imaginary numbers, but we're not there. X squared minus 9, however, look at this. This is another difference of 2 squares because you got a minus, and x squared is a perfect square, and so is 9. So this is actually going to factor further. So this right here is going to break down to x and x plus 3 minus 3. And your total answer is right there. X plus 3, x minus 3, and x squared plus 9. These factors could be in any order, doesn't really matter. So if you like to put the x squared plus 9 at the end, that's fine. But that's as far as you can go. So that's a classic example of a double dots. Difference of 2 squares, and then one of them breaks down again. Okay, last example here. And we're just trying to show you some more advanced ones. And it's very easy if you know what's coming and someone says, hey, here are 20 difference of two squares problems in a row. Boom, boom, boom. But what's hard is picking them up when they're mixed in with other problems and your other methods. And sometimes you have to combine steps. So that's what I'm trying to show you a few examples of here. So number 5 certainly looks like a more complicated problem. Is there a greatest common factor I can take out of all 4 terms? No. Well, then if I can't take the greatest common factor out, there are 4 terms. The next thing I'm going to try is grouping, right? So grouping here, what can you take out of that first group? I can take out of 12 and 8, I can take out 4. And out of x cubed and x squared, I can take out x squared. So I'll take out 4x squared, and that will be 3x minus 2 when you do that. Out of the second group, it starts with a minus, so you'll want to take out a minus. And the only thing you can take out of 3 and 2 is 1, so in this case I'm going to take out minus 1, or negative 1 if you prefer. And what's going to be left on the inside there? That would be 3x, and negative 1 times negative 2 will give you that positive 2 you're looking for, which is kind of what you want anyway, because you know with grouping, if it works, you're supposed to get the same quantity here and here, so that I can then factor out that common quantity of 3x minus 2, and the other quantity is made up of those coefficients, 4x squared minus 1. Again, the order doesn't matter there if you like to put the 4x squared minus 1 first. But are we now done? And here's where you got to look. When you get down to things that are made up of binomials, look for those difference of two squares. They both have minuses, but only one of them is actually a difference of two squares, and that's right here. 1 is a perfect square, and so is 4x squared. So 3x minus 2 cannot break down any further, so that's just going to stay the same. But 4x squared minus 1, what times itself gives you 4x squared? 2x. So 2x and 2x. What times itself gives you 1, or in other words, the square root of 1? That's 1. 1 plus, 1 minus, and now it's totally done. None of these can go any further, so there's your completely factored answer. So that was grouping and then a difference of two squares. So these last few problems were all multi-step and kind of combinations of different methods you've learned. Greatest common factor, dots twice, and grouping, and then dots. So, keep an eye out for it, practice, and if you have any questions, just ask.